Thank you for inviting me to discuss this paper. Before we get into the weeds of it, let me say it's an important topic and an interesting paper, and I'm going to offer some comments in the spirit of constructive criticism. Also, we had a long day today, and I was revising my discussion, so no duration effects are negative. So basically, let's see what happens. I'm going to start with some background. This is sort of not specific to this paper. This is kind of where we're starting in terms of what we are thinking about in asset pricing literature on this topic. I'm going to refer to a couple of papers of my own with different co-authors that look at how innovation shocks are priced in the cross-section of asset returns, which is what this paper is about. Now, we know that technological progress is embodied to a significant degree in capital goods. A lot of what we see as technological improvements is our ability to create new technology or new productive assets that are more efficient, more productive than the old. And that has natural implications for the cross-section of stock returns, because what it means is that if you look at capital goods of different vintages, the future vintages will benefit from this kind of technological progress, but the old vintages do not. And that creates natural heterogeneity in risk exposures, which applies not just to vintages of capital, but also to firms. Are they rich in capital or are they rich in growth options? That matters. So this is the reason why these types of shocks, as opposed to labor-embodied shocks, are kind of natural to think about when we think about the cross-section of stock returns. Now, what is puzzling about pricing of these shocks is that what we infer from financial markets is that these types of technological shocks, embodied shocks, carry a negative price of risk. This is kind of odd, because this technological growth is ultimately good for the economy. It raises output and consumption, maybe not in the short run when there is a redistribution of effort from consumption towards producing capital goods, but in the long run, this is good. It raises kind of in a permanent way output and consumption. Why is it then that these shocks are priced as if these are high marginal utility states? What this suggests is that there is an important difference between the effect of these shocks on the average consumer in the economy versus their effect on the marginal investor in the financial markets. That is not the same, and if you want to understand how these shocks are priced, it's critical to think about heterogeneity and imperfect risk sharing, so that we cannot use a representative agent model. We have to think about impact on the investors as opposed to an average agent. I should say that the reason why this is kind of an important topic, I think, is that this goes beyond just asset pricing. This issue is important for other things in economics and beyond. So you could think about inequality, social tensions, political economic implications of innovation. This is kind of first order, but here we're focused on the financial implications of that. So the key to resolving this, at least in our papers, this is the route we pursue. That we're saying that basically gains from innovation are not captured fully by the equity market investors, right? By the owners of the firms. So there is some kind of dissipation of value. Value is being created, but equity owners don't capture all of it. So where does it go? Some of it could be captured by innovators and the supporting cast, basically, so it doesn't get captured by the owners of shares in the public markets. Some of it can be captured by the workers. So essentially, there are these different dimensions where value can get dissipated, and that's the reason why the investor in the equity market looks different from the average person in the economy as far as how they're exposed to these shocks. Now, to make these states, high innovation states, high marginal utility states, you have to appeal to idiosyncratic risk. You have to say that, yes, so as far as the first moment goes, these are good states, but there is a lot of risk involved, and on a risk-adjusted basis, they're bad states. So the conclusion is that even though innovation is good for the average person in the economy, it's bad news, potentially, for the investor in the stock market. Now, this paper is focused on a particular type of innovation, which is labor-displacing automation, right? So it's really about robots. And not all of innovation is like that. It could be actually friendly to labor, but this is looking at the labor-displacing, labor-saving innovation. Let me summarize quickly kind of what the paper does. Basically, it develops a two-period general equilibrium model. In this model, firms face a decision to adopt a new technology, which is going to replace labor with capital. And as a result, what happens is that as this technological progress takes place, some firms end up adopting the new technologies. They become more efficient. There is competition between firms that adopt, firms that do not. The end result is that profits of these firms actually fall. particularly when you take into account the fixed adoption cost. So this means that firms that are rich in labor, the labor that can be displaced by innovation, are negatively exposed to these innovation shocks. It's not surprising. Then why is the shock priced negatively? It's because of idiosyncratic risk, which is added on top of it at the end. So idiosyncratic risk, if you have enough of it, it flips the sign of the price of risk. Okay? Now, this paper creates a factor, KML factor. This is the long-short portfolio of firms that are rich in capital versus firms that have a lot of displaceable labor. And this factor is supposed to mimic these technological automation shocks. And then it provides empirical support for the properties of this factor and exposure to this price. I'm going to talk more about the exact kind of empirical tests, but that's sort of the overview. Now, let me say a few things about the model. So the model is static. It's 2 periods. And despite of that, it's very parsimonious, sort of simple, yet it doesn't have a general solution. So we don't actually quite know the qualitative properties, which is kind of restrictive. What the paper does, it provides numerical example that, yes, for certain collection of values, it does seem to work. And in particular, if you look at this plot in the middle, what you see is the following. This dashed line is what would have happened if firms could have adopted new technology without paying the fixed cost, and their profits would have gone up. Of course, they have to pay the cost, and so their actual profits are the solid line, they're lower. And the blue line are the profits of the firms that don't adopt the new technology. They kind of get hurt, of course, by competition from the adopters. And so in equilibrium, firms need to be indifferent between paying the cost and switching and not. And so you end up at this point, which is negative. So it looks like both of these adopting firms, not adopting firms, they all lose. And this is kind of the nature of the phenomenon that there is a factor in stock returns. And the pricing of this factor is really idiosyncratic shock to the labor income. All right, so now the question is this proposed mechanism for displacement really new? And these fixed adoption costs, are they essential? So I'm not sure that the answer is positive to both of these. So let's kind of think about it. It's a little bit difficult because the model doesn't have an explicit solution. So we cannot really ask what would have happened if we remove these costs. One can do it numerically, but I cannot do that. But here's kind of the argument. We want to create a situation where a positive innovation shock hits, aggregate consumption goes up, but despite of that, the value of firms in this sector, this labor-rich sector, falls. And then to make that a bad state, we just add idiosyncratic risk, which is an extra ingredient. So let's use the constraint, this market clearing, that says that consumption in the second period is equal to the dividends and the wage income. Dividends from sector 1, this is the sector of interest. Dividends from sector 2, which is already automated, plus wage income from both sectors, which is aggregated within each household. Now, what we want is D1 to decline as a result of the shock. So as we saw from the picture, that happens. So the dividend in the first sector goes down. We want consumption to rise. It probably rises, I'm not sure, but one can check. It probably rises when there is good news in terms of innovation. So aggregate consumption rises. Now, how is that possible? That the dividend in the first sector declines, consumption rises. So other things have to rise. So let's see what could be happening. D2 could rise. So that's possible. That is not exactly what we think about as displacement, because remember that consumers in this economy, they own all of the firms. So they're going to collect D2 and D1. So if one sector benefits at the expense of the other, yeah, that's going to show up in the cross-section of stock returns, but that is not exactly displacement as far as consumption of the stockholders is concerned. So it's, the action is really all in the wage income. So what happens is that the wage income rises when there is bad news for the firms in the first sector, and as a result, aggregate consumption is higher, but it's bad news for the stock owners. It's bad news for these cash flows. So why does the wage income rise? It's because the workers who get displaced, they move to producing capital, and wages in that sector rise when there is a new technology. In fact, this kind of technological innovation is friendly towards labor in that sector. It's complementary to labor. And so wages rise, and this is how we could get high consumption despite of the value of the firms falling in the first sector. So this mechanism that essentially the stock market value of these firms falls, but wage income rises, and that's the difference between stockholders and average consumer. That, of course, is not specific to this model. That shows up in other models. Then the question is, are fixed costs essential for the displacement mechanism? I don't think they're essential for any of this. These patterns would show up without the fixed costs. All right. Now, a few more comments. So basically, what happens after the technology adoption? In this paper, it's a two-period model, so the world ends. But in reality, think about what's going to happen in the future periods. After the firms pay the fixed cost, and that shows up in the dividend in the second period, then from that point on, it's all kind of good news, this technological adoption. And stock prices in a dynamic model, they're going to discount all of the future cash flows. So I'm not sure that these patterns are going to easily survive or survive at all when you really make the problem dynamic. So the pattern can actually flip. So this is one reason why it would be quite useful to develop a proper dynamic model. For some questions, it doesn't matter, you could get the insight from two periods, but here, two periods has artifacts. And that's quite important, I think, to relax that constraint and look at what happens beyond. Another reason for thinking kind of longer term is that this is really a model of transition. Firms start using this kind of displaceable labor, and then they automate. But that's a one-time thing. And then what's going to happen in the future? The same mechanism is not going to play out. It's kind of like people moving from the countryside to work in the city. It's a big deal when it happens, but that's not going to happen in steady state. So existing previous models, they kind of describe the steady state effects of innovation. But this seems to be about the transition path when you have this automation replacing labor. Is that what you think is going on in the historical data and stock returns? It's a particular type of phenomenon, but it's not a general situation, and it's not going to describe kind of future for the most part. So now, let's talk about the empirical test. So what the paper does is it sorts firms on this measure of how much replaceable labor they have. And this basically is based on the object that looks at this L routine. L routine is the product of the number of workers in the firm and an industry level measure of how routine the tasks are on average. So we don't really know what's going on within each firm, but we're kind of inferring at the industry level how routine the tasks are on average and assigning that to the individual firms. What happens as a result is that, and the paper acknowledges that as you sort on this measure, you're sorting mostly across industries. Some industries have a lot of routine labor, some do not, and that's kind of the sort. So the KML factor is mostly a long-short industry portfolio, kind of like the IMC portfolio that Dimitris constructed and we used in our paper as well, which has obvious limitations. Whenever you do long-short across industries, you have to wonder what is different between these industries and what else you're picking up. What exactly is this factor mimicking, right? So the paper tries to figure out to what extent this factor is a good mimicking portfolio for what we think automation shocks, which I think is a good thing. So it's looking at some quantities and some cash flow results, not just returns. So KML correlates highly with shocks to the quality-adjusted prices of investment goods. That was the graph. That was kind of so striking that the two series correlate. So that's good. That seems to be supportive evidence. Of course, quality-adjusted price of investment goods, that is not about automation. That picks up all sorts of technological progresses. Some of it is labor augmenting, some is labor replacing. So it's really not the right measure, but it's something. It's a cousin of the right measure, the second cousin of the right measure. Then KML betas forecast future exposure to the I shock. So that's good. They predict risk, exposure to the fundamental factor, with the caveat that I shock is not ideal, but it's what we have. KML betas predict how cash flows respond and how firms respond in terms of their labor, in terms of their capital level. So that goes in the right direction. Basically, these labor-intensive firms, they end up with less labor following positive shock, so that's good. It doesn't affect the capital. It's unfortunate because you'd like to see them replacing labor with capital, but they end up with less labor. So that's all kind of supportive, but it's sort of indirect. It would be nice to get more direct evidence. And kind of one the cheap shot is to say, well, let's try to do this within industries. We can sort on KML betas within industries and see if we start getting the same effects and the same properties across firms. It would be nice to see that this is not just differences across industries. Now, in the spirit of looking for direct evidence, why stop with the I shocks? We could look at things like patents. In particular, we can look at different patent types, those that are more about automation versus other stuff. We can connect patents to different types of firms. So we can get a closer look at the nature of innovations. This data exists, right? We have textual information about patents. We have estimates of their market value. We know which firms are innovating. So one can do a lot more. Of course, if you use Danish data, for example, then you could really do a lot more. So this is a recent paper. It's actually interesting. So I ended up sitting on a plane next to this guy. He was going from Boston to San Diego, right? What are the chances? And he was reading his job market paper. So it's using Danish data about how robots displace labor. And there they know the robots, their names, their hobbies, and they know even more about the workers. And they look at endogenous adoption of robots and how people move and where they end up and how they affect it. So you could learn a lot more in detail. So it's going to be much more direct. Now, a couple of things. So this is last but not least. We find qualitative support in these regressions, but there is a question, quantitatively, is that really enough? So the cash flow effect goes in the right direction, but is that what explains movement in stock prices? These effects need to be sufficiently persistent and large to say that this is why stock prices move the way they do. And you cannot answer that question in this two-period model. So that's another reason for having a proper dynamic model. Another issue is that these workers, these routine task workers who are being replaced, they are probably not the marginal investors in the equity markets. And what we find in this paper with Dimitris and Larry and Jay is that people who actually seem to be most exposed to innovation shocks are actually the highly paid workers. They are the ones who end up with the most idiosyncratic risk, not the guys in the middle, which is kind of good for asset pricing because they're more likely to be marginal. They're the richest people, at least in terms of income. But they are not the ones who are being replaced by robots because they are involved in routine tasks. So that's another wrinkle. So essentially, one has to think harder about who is being replaced by robots and are they really relevant for pricing in the equity markets and who are we leaving out. So in conclusion, I think it's an interesting paper. The topic is important. It's trying to establish a broad kind of evidence on the technological shocks, automation shocks, and how they affect equity markets. What I think one could add is that one can go to a dynamic model to get beyond some of these limitations of a two-period model, learn a bit more quantitatively, and deal with this transition path versus steady state issue as well. And of course, it would be great to get direct evidence that what we're finding really is automation and not something else. Thank you.